How to make any function asynchronous in Python 3.12. Introduction. Asynchronous programming in Python allows you to write code that can handle multiple tasks at once, without waiting for each task to complete before starting the next. This is particularly useful for I/O-bound operations like network requests or file reading, where tasks often involve waiting for external processes. In Python 3.12, making a function asynchronous involves leveraging the async and await keywords, introduced in earlier versions but refined over time. This tutorial will guide you through the concept and process of making any function asynchronous in Python 3.12. Understanding asynchronous programming. 1. Synchronous versus asynchronous. Synchronous code executes one line at a time. If a function performs an I/O operation, it blocks the execution until the operation completes. Asynchronous code allows other tasks to run while waiting for I/O operations to complete. This is achieved by using async functions and await expressions. 2. Event loop. Python uses an event loop to manage asynchronous tasks. The event loop handles scheduling and execution of asynchronous tasks and ensures that your code can run other tasks while waiting. Making functions asynchronous. 1. Defining asynchronous functions. To define an asynchronous function, use the async def syntax. This transforms the function into a coroutine, which can be paused and resumed, allowing other tasks to run in the meantime. 2. Awaiting other coroutines. Inside an asynchronous function, you can use the await keyword to pause execution until a coroutine completes. This allows the function to yield control and run other tasks while waiting. 3. Running asynchronous code. To execute asynchronous code, you need to run it in an event loop. This is typically done using asyncio.run in Python 3.12. This function starts the event loop, executes the coroutine, and closes the loop when the coroutine is finished. Practical steps. 1. Identify blocking code. Determine which parts of your code involve I/O operations or other tasks that could benefit from being asynchronous. 2. Convert functions to coroutines. Change the function definitions to use async def and update any blocking calls to use await. 3. Use asyncio for execution. Use asyncio.run to execute the asynchronous functions within an event loop. 4. Handle exceptions. Ensure that you handle exceptions within your asynchronous functions. Use try and except blocks around await expressions to manage errors effectively. Key points to remember. Asynchronous functions. Use async def to define functions that are asynchronous. Awaiting tasks. Use await to pause the execution of a coroutine until another coroutine completes. Event loop. Use asyncio.run to manage and execute asynchronous tasks. By converting functions to asynchronous using these principles, you can write more efficient and responsive code that performs better under concurrent load.